All right, where was I? So yeah, so I had just poured my alcohol in there, and if you can see, there's the layer of the strawberry pulp and mush with the more solid parts. Then there's the alcohol on top, and right where the two meet at the interface, you start to see this weird stringy substance. And what you want to do is really slowly take your straw pipette and try to gather some of this stuff up and kind of get it around the tip of your straw or whatever you're using. And you can kind of spool it around almost like it's string, and there you are. Some quality strawberry DNA. Now think about it. I get it. It looks kind of weird. Maybe I just sneezed and kept it in this jar for some reason. But think about it. Think about the shape of DNA. What type of shape of molecule it is. It's a really, really long twisted molecule. And this is kind of long and stringy, and when you're spooling it around your straw, it kind of acts like spaghetti. So it kind of makes sense when you think about it, that a long stringy molecule, when it's all clumped together, would come out of solution as a long stringy goop. So in your digital notebooks, what you would do is do a sketch. Draw what that looks like to you. Try to add a little bit of color. It's got a slight pink tinge. Notice that the green is completely irrelevant now of the dish soap. So there you have that. I'm going to put that back in solution. Still floating in there. So now I'm going to try the same thing with my good friend banana. So I had another glass, but then I don't know what to do with it. Here it is. This will work. So same thing, right? We're gonna take our coffee filter. You can even kind of shove it in there a little bit. And by the way, if you're doing this at home, you don't have to do the banana part, of course. But since we didn't really talk about it much, pause the video if you haven't already and make a prediction. What do you think the banana is going to look like? Obviously, it's going to be a different color, but do you think it'll look the actual DNA? Do you think it'll look like the strawberry's DNA or something else? Like I said before, I haven't done this with banana, so come on, bag. You know, they were trying to be helpful. There. Oh, okay, actually. Makes it easier to pour. But they weren't. Okay, this stuff is really kind of interesting. Oh man. Alright, let's go. Let's get it out. There it is. Oh, wow. That's really something, isn't it? So remember, you don't have to like get every tiny little bit from the bag. And if I were really going to be meticulous about this, I'd leave it like that and let it drip through, but that would take quite a bit of time. So I'm going to take it and I'm going to gently encourage the banana, or at least its DNA, to come out. This is where having a test tube would come in handy. Which I was just in school, but I didn't take any home. So you just keep going. And it can be this slow with the strawberry too. And if it is, that doesn't mean you necessarily did anything wrong. It's just how it is. Filtering, like, to really filter something takes a very long time anyways. Not so much when you're using your, like, if you have one of those filtered water pitchers, that doesn't take much time, but if you're doing it like for chemistry, Well, you'll probably find that out. It takes a while. There's hardly anything in here. Alright, now we get something going. Now we're dripping. I just need to get enough so that I have enough liquid in there to get the skewer around. Alright. So if I were being fancy, I might cut this portion out. Maybe I'll do that anyways, I don't know. Alright, but this is one and done. I'm not doing this lab multiple times, even if there are bloopers included. Alright, so the liquid, you know, it almost looks like a pulpy lemonade. Okay, well, a little bit more. So I've gotten a lot coming through here. Sometimes it'll come through the sides, which is okay as well. Alright. Okay, well, let's give it a shot. And you really don't need a lot of the alcohol. Oh wow, okay, cool. And you really want to do it carefully down the side, like I just did, so that you don't swirl everything together. Now, I'm not sure you're going to be able to see, but this is crazy. It has really separated into, I mean, looking down into it, I can just see all the DNA that just precipitated or came out of solution. That's what precipitate means. That's why when we have rain, they call it precipitation, right? Because it came out of the cloud. It's a little harder to get out, but there. It's not quite as connected and stringy as the strawberry was, but it's really it almost formed like a ribbon inside. It was pretty cool. And then you can put it back in solution and kind of reconnect it a little bit. So I want to get even more out. Oh, here we go. Come on, you. Oh. Almost. Come on, friend. Well, I don't know how much you can see in there, but there's really quite a lot of DNA. And you saw how much banana went in. Not very much. So it's the banana is a little bit different, but it's even more striking because the DNA appears to be much more in contrast with the rest of the stuff. So I highly recommend doing the banana as well. However, if you do even just the strawberry and upload that, definitely bonus points for anyone who does that, and even more bonus points for anyone who does the same experiment with the banana. So, I hope this was helpful. I hope it showed you what was going on and gave you enough information to answer all the questions that you're going to have to, and to do it yourself if you like. So, be safe if you're going to do it, and be well and stay safe out there if you go. Alright, STEM, it's Trachtenberg. I'll see you soon.